Hi everyone, welcome to lecture number 4 of counting under GATE data science course. So in this lecture we will learn about combination. So in the previous 3 sessions we have seen rule of sum, rule of product, factorial and the number of arrangements, which is permutation. So now we will see combination. So a combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of selection does not matter. So what do I mean by this? So in very simple terms, permutation is arrangement and combination is selection. So when you have to select R items out of n objects, it is combination. When you have to arrange them, it is permutation. So just selecting them, like let's say we have a 15 player squad for World Cup, right? But 11 players play a certain cricket match. So the selection committee for every match selects 11 player out of the 15 players to play a match. It doesn't matter, right? Actually, there is an order there as well, right? In which order they will bat or bowl. But right now, let's consider selection. Like I got selected for today's match or not. So it is a selection of 11 people out of 15 people to play a match. That is combination, right? So you can select the items in any order. So the number of ways to choose, we can also call this choose, right? We are choosing objects, we are selecting them. So that's why choose, n choose R. So the number of ways to choose R items from n objects is considered as a combination. It is written as NCR and is read as n choose R. N permute R before and now we have n choose R. Choose R objects out of n objects. So like how will we do it? Again, like let's say we have 5 objects. Okay, and I have to choose any 3 of them. Okay, so basically I can choose 1, 2, 3. I can choose 1, 2, 5. This is a different selection of people, right? I can choose 3, 4, 5. This is a different selection. But 1, 2, 3 and 1, 3, 2 are same. This is the difference between permutation and combination, right? Previously we saw that 1, 2, 3 is different and 1, 3, 2 is different because we want to arrange them as well. But now we are not arranging them. We are just selecting 3 items out of 5 items. That's all. Okay. So these two will become same. So in how many ways can we do it? So just use NPR, whatever we have learned so far. So let's say out of these 5 objects, I have to select 3 objects. So firstly, let's arrange them also. Let's say I arrange them also. Then I know that the number of ways is N5P3. This is the number of ways in which I can select 3 items and arrange them. Like 1, 2, 3, 1, 3, 2 and so on. And the last arrangement will be 3, 4, 5. Right? And 5, 4, 3 will also be a arrangement. So, but here again, whenever you overcount, we see there is an overcount, right? These two selections are same. 3, 4, 5 and 5, 4, 3 are same. We are overcounting. Whenever we are overcounting, we will divide. So how much are we overcounting? So very easy, right? Like it's same as we did before, where 2 vowels or 2 letters were repeating. So here also 1, 2, 3 is like a repetition, right? We cannot repeat it again and again. So for every such selection, for every selection of 3 objects, when we are actually permuting, we are repeating it 3 factorial times. So in every such permutation, what happens? What exactly is happening? So when we are selecting, let's say 1, 2, 3. In 5P3, we will have 1, 2, 3 also and 1, 3, 2 also. We will have 3, 1, 2 also. We will have 6 arrangements. And similarly for some other selection, let's say for 2, 3, 4, this is a different selection. I will again here also I will have 6 different permutations. 3, 2, 4 and so on. So for every selection, I am repeating every selection 3 factorial times. Because that is the number of ways I can arrange these 3 numbers, right? So here we are overcounting every selection 3 factorial times. So I have to divide it by 3 factorial. Again, like same logic which we applied in the last lecture. Whenever you overcount, just see how many times are you repeating every occurrence and divide by that. So this is what the number of ways of selecting 3 items out of 5 items will be. So for any general n, NCR will be what? NPR upon R factorial, because while doing NPR, you are overcounting every selection R factorial times. That is the number of ways to arrange those R letters among themselves or R selections among themselves. You don't want to do that. So this will be the number of ways to choose R items out of n items. And if you want the complete formula, we know that NPR is what? N factorial upon n minus R factorial. And we have divided by R factorial also. So this will be the formula for NCR. Okay. And there are two notations to write NCR. Some people write it this way. Some people write it in the big bracket notation, which is like this. In big bracket, you write N and R. This is also NCR. This is also NCR. And this is the formula. N factorial upon n minus R factorial, R factorial. Cool. So again, like small trick, how to calculate. I told you, let's say if you want to calculate, let's say 7P3. It was what? 7 into 6 into 5. Right? It should be very quick. 7 into 6 into 5. You don't want to go into factorial also. If you want to calculate 7C3, always remember it is divided by this factorial also. So it will be 7 into 6 into 5 upon 3 factorial. Okay? That's all. But just divided by R factorial also. So that's how you calculate it. It will be very simple. Okay, once you learn this technique, the calculating NPR, NCR will be very simple, like very easy. It will be very fast. And also, I'm not sure if the calculator contains C or P symbols. They don't. So you will have to do this anyway. Okay. So yeah, like you have to do this. The calculator can help you in calculating this multiplication, but it won't calculate 7P3 for you, right? So you need to know the logic at least. Cool. So now there is a mathematical equation written here, and this is called, this equation is famously called combination as recurrence. So if you are a computer engineer, you know the term recurrence, I'm assuming, but yeah, like shortly saying, like you want to break the problem into simpler problems and solve those problems and keep doing that, okay? And we write recurrence equations in computer programming language in a form called recursion. Okay, so yeah, but yeah, you don't need to know all of this. It's just breaking NCR into problem of smaller size. How? This is n minus 1 CR and this is n minus 1 CR minus 1. So basically choosing R items out of n items, the number of ways to choose R items out of n items is equal to the number of ways to choose R items out of n minus 1 items plus the number of ways in which we can choose R minus 1 items out of n minus 1 items. So firstly, logically, let's think why is it so? Okay, then we will go to the proof. So why is it so? Let's say we have n objects. Okay, let's take n equal to 6. And let's say R is equal to 3. I want to select 3 items out of 6 items. So now what happens is, consider the first element. Okay, and right now, like I know this is a math lecture, but I will go into computer science a little bit just to explain you the logic behind the recurrence. Okay, and any DP problem, okay, dynamic programming or like recurrence problems, generally like problems which involve recursion in algorithms. If you go into computer science, if you are a math student and just learning data like data science, you can ignore like the next 2 minutes. Okay, so when you involve dynamic programming, right? So you want to break the problem into smaller chunks, problems of smaller size, and they will be repeating in some sense. Okay, so this is the standard way to solve such problems. You have a large problem, you have 6 items, you have to select 3. Consider the first item. Okay, always go with the first item. Like consider the first item. What options do I have? Either I can take it or leave it. In the selection committee, okay, like this is KL Rahul. Okay, 15 players, either he will play or not play, right? So in the selection of 11 players, either the player will be present or not present. So there are 2 options. Either take one in the selection or leave one from the selection. Or either take one or leave one. Okay, you have 2 options. Or means what? Rule of sum. In how many ways can I choose 3 items out of 6 items in which I must take one. I have to take one. If I have to take one, basically, then I will have to choose 2 items out of remaining 5 items. Right. Since I have already taken one item, now the problem reduces to I have to choose 2 items out of 5 items. And if I leave one, then how many options do I have? Again, I have 5 items, but now I have to take 3 items. Because since I have not taken one, still I have to make a team of 3 people, right? So I have to choose 3 items out of 5 people. This is what 6C3 is. Okay, for the first item you have 2 options. So that's how the recurrence came up. So NCR is n minus 1 CR minus 1 plus n minus 1 CR. You either take it or leave it. This is leave it, this is take it. Okay. So and now mathematically also you can, with the formula you can very easily prove it. So let's just expand the RHS. RHS is n minus 1 CR plus n minus 1 CR minus 1, which is formula wise it is n minus 1 factorial upon NCR. So just remember, like for you to remember, NCR formula was n factorial upon n minus r factorial Okay, so it will be n minus 1 factorial upon n minus 1 minus r factorial plus this will become n minus 1 factorial upon, so this will become n minus 1 minus r minus 1 in brackets, minus r minus 1 in brackets, so it will become r plus 1, minus minus will become plus. Okay, you can do this easily, this minus this, so it will become n minus 1 minus r plus 1 times r minus 1 factorial. So you can just write it straight away, minus 1 plus 1 gets cancelled, this becomes n minus r factorial in the denominator. I'm just simplifying it, this becomes n minus r factorial. So now take common, whatever you can take common, just take it common. So in the numerator n minus 1 factorial directly comes as common. In the denominator what can come common? See, here we have r into r minus 1 factorial. R factorial is what? R into r minus 1 factorial. So this is larger. So we can only take r minus 1 factorial common. And here this is n minus r factorial is what? N minus r times n minus r minus 1 factorial. This is what n minus r factorial is, right? So this is what we have here. So I can take this thing as common. N minus r minus 1 factorial common. Okay, so what will it become here? This will become 1 upon r. This will become 1 upon r. Only r is remaining, and this will become 1 upon n minus r. Okay, so this becomes n minus 1 factorial upon r minus 1 factorial n minus r minus 1 factorial times, here you take the LCM, so r times n minus r, and above you will have n minus r plus r. So r and r got cancelled, this becomes n. So this n times n minus 1 factorial is what? N times n minus 1 factorial is n factorial. And in the denominator, r times r minus 1 factorial is r factorial. N minus r times n minus r minus 1 factorial is what? N minus r factorial, which is NCR, which is LHS. Okay, so mathematically you can prove it anyway, but this won't be required for exams. But yeah, you should know, like this is simple. Okay, but yeah, like just think of the logic. Why is it so? And why do we learn this? It has a huge implication in computer science. When you want to calculate, like when you have, let's say, lots of numbers, okay, and in a computer program you want to calculate NCR for many pair of n and r, you generally go with this way. Since it's like a DP table, right? You have already calculated NCR for all n equal to 5. Let's say for n equal to 5, you have calculated 5C1, 5C2, 5C3, 5C4, 5C5. Then for n equal to 6, you don't need to apply the factorial formula again and again. You can just use this. Use the DP table and populate n equal to 6 also. Okay, so I will not use computer science terms, but yeah, in constant time you will be able to fill this table, every element of the table. Okay, So for N and R, if you have the appropriate space, you can actually calculate NCR for every combination in N into R time. Okay, so yeah, like that's the application for this formula. Okay, now next axiom that we have in combinations, very simple, K selection is equal to K rejections. Why so? So again, like let's go to the cricket example. 15 people team got registered for every country in World Cup. Every match 11 people play, right? The number of ways in which we can select a team of 11 people out of 15 people for one match is 15C11. We know that. Okay, number of selections. But actually, think about it. Every time when you are making a selection, you are also making a rejection. When you select 11 people, 4 people remain. So every selection of 11 people is equivalent to a rejection of 4 people. Right? So in simpler example, like let's say A, B, C, D, E, F. Let's say I want to select 4 people. N is equal to 4, N is equal to 6, R is equal to 4. I have to select 4 people. So let's say one such selection is A, B, E and F. Every selection of 4 people is equivalent to a rejection of 2 people. What 2 people got rejected? C and D. Right? Every selection will have a corresponding rejection, a unique rejection. So similarly here, 4 different people have to got rejected if 11 different people are getting selected. So that's why, think about it, there is a one-to-one mapping. Every selection will have a rejection. So, and if you're selecting R people, you are rejecting N minus R people every time. So that's why NCR will always be equal to NC N minus R. Right? This is rejecting R people, and this is selecting R people. Right? So N choose R will be equal to N choose N minus R. Mathematically very easy proof. So just write N choose N minus R. Like if you just write it, it is like very simple. It is N factorial upon N minus R factorial times R factorial. So here R is N minus R. So this is R, and N minus R will become N minus N minus R. So plus R. So this will become N factorial upon N and N will cancel. This will become R factorial. This will become N minus R factorial. This is what NCR. Okay. So K selection is equal to K rejections. So again, like an example from World Cup match. So how many matches are being played in Cricket World Cup 2023? These are some facts. There are 10 teams playing, and each team plays with each other team once in group stage. We should not call it group stage, like yeah, but like previously we had group stages, right? So yeah, and then we have 2 semi-finals and a final. Very easy, very easy problem. Okay, IPL wala problem is slightly difficult. Like there you have, like they made a like huge thing, right? There are 2 pools. Teams in one pool play with like the same pool once and the other pool twice and something like that. So yeah, but here yeah, it's much simpler. So you can count that as well. Okay, just try to do the IPL problem as homework. So this is simpler, 10 teams. So in the league stage or group stage, like how many matches will be there? Every team plays with each other team once. So we have to count the number of pairs. India plays Australia, India plays Pakistan, every pair possibility basically. So in how many ways can I choose 2 teams out of 10 teams? 10 choose 2, 10 C2. This is the number of different pairings, okay, of teams which is possible. So this is the number of matches which will be played in group stages, plus we have 2 semi-finals and a final, so 3 more matches. So 10 C2 is what? Again, like always do it this way, 10 into 9 upon 2 factorial plus 3, so which is 45 plus 3, so 48 matches will be played. Okay, cool. So here we have next problem. A question paper consists of 16 questions with 8 questions each in set A and set B. So we have two sets. Set A containing 8 problems. Set B containing 8 problems. So there are total 16 problems. Students have to answer 5 questions, selecting at least 2 questions from each set. In how many ways a student can select questions to answer? Okay, so I'll give you like just pause the video and try to solve it on your own. Cool, I'll solve it. So basically you have to select 5 questions out of these 16 questions. If there had been no such restriction, you have to select at least 2 questions from both the papers, the number of ways would have been 16C5. Selecting 5 questions out of 16 questions, right? But this is not the case here. Here we have to select at least 2 questions from set A and at least 2 questions from set B. So basically either you can select 2 questions from set A and 3 questions from set B, or you can select 3 questions from set A and 2 questions from set B. This is the only 2 possible ways which you can accomplish this task, right? Again, everything is a task. So either you do task T1 or you do task T2. Or means what? Rule of sum plus. So you select 2 from set A, 3 from set B, or you select 3 from set A and 2 from set B. So in how many ways can we do this? Very simple. 8C2. So here now what happens? This task itself can be broken into 2 tasks. Select 2 questions from set A and select 3 questions from set B. Here we have an AND, right? Here we don't have an OR. We don't have an option. We have to select 2 from set A and we have to select 3 from set B. Similarly, here also we have an AND. 3 from set A and 2 from set B. So this task itself has a rule of product. AND means multiply. So 2 from set A means 8C2 into 8C3. And here 8C3 ways to select 3 questions out of 8 questions, and 8C2 ways to select 2 questions out of 8 questions. So this is your final answer. You have to add these 2. Okay, so it is basically 8C2 into 8C3 plus 8C3 into 8C2. Basically we will multiply it by 2. Okay, so like quickly how to do it: 8C2 8 into 7 upon 2 factorial, 8C3 8 into 7 into 6 upon 3 factorial into 2. 6 6 2 2. It is 8 into 6 square, 56 square, whatever is it, 3136. Okay, cool. So now the last example, one of the most important examples of combination. What is the number of different diagonals that are present in an n-sided polygon? Okay, so let's say we have a polygon of side 5. Okay, how many diagonals can we have here? So this is one diagonal, 2, 3, 4, 5. For n equal to 5, we have 5 diagonals, right? So how to solve this? How to calculate it for any possible n? How to calculate it for any possible n? That's what you want to see. So let's see it. So think about it. Firstly, like there are 2 ways to solve this problem. Firstly, I will do the combination way. Okay, let's say there are n points in space: 1, 2, 3, 4, 5. Here we want to, in some sense, create a complete graph, right? See, if I create all possible diagonals, here I want to create all possible diagonals. It means basically I'm connecting every point to every point in that polygon, but not the adjacent points. See that if I connect this point to its adjacent point, this is basically the side of the polygon, not a diagonal. But let's forget about that for now. Let's say I have n points in this space. In how many ways can I connect one point to another point? So it's basically the number of pairings. In how many ways can I choose 2 points out of 5 points? 5C2. There are 5C2 ways in which I can choose 2 points out of 5 points, which is 5 into 2, 4 upon 2, 10. There are 10 such pairings. Let's connect everything. 1 with 2, 1 with 3, 1 with 4. These are 10 possible ways. 1 with 5, 2 with 1, 2 with 3, 2 with 4, 2 with 5, 3 with 1, 3 with 2, 3 with 3, 4, 3, 5, 4, 1, 4, 3 and 4, 5. Okay, so there are 10 possible combinations of 2 points out of 5 points. So these are 10 different lines which I draw. But out of these 10 lines, 5 lines belong to the side of the polygon, not the diagonals. Out of these 10 lines, 5 lines are actually side of the polygon. So in any such example of n, let's say you have n-sided polygon, you first connect everything, okay, everything with everything. So you will have nc2 possible different lines which can be drawn. But out of these nc2 lines, n lines will be from the side of the polygon itself, and the remaining are diagonals. For example, here these 5 are sides and all remaining are diagonals. So here for n, nc2 is all possible pairings, but there are n sides. So this is the number of diagonals, okay. So, and there is another way to do this as well. Let's see that. Very simple, okay. Okay, so what is the other way to think about this problem? Okay. So let's take any vertex. I took this vertex 1. Okay, so how many, so I want to create a diagonal starting at vertex 1. I want to create a diagonal starting at vertex 1. I have more vertices, 2, 3, 4 and 5. So basically, I want to connect 1 with some other vertex, then it will be a diagonal. So a diagonal is defined how? You can start at a vertex and end at any vertex which is not adjacent to, you can end at any vertex which is not adjacent to this particular vertex. So if you start at 1 and end at 2, it will not be a diagonal, it will be a side. So you can end at any other vertex which is not adjacent to it, like you cannot end at 2 or 5. So basically, you connect this vertex to how many options? How many options will you have? 3 and 4. Basically, you cannot connect it to 1 itself or 2 or 5. So you have to connect every vertex to n minus 3 other vertices. You have to connect every vertex to n minus 3 other vertices. Okay. So similarly, like if you have a large polygon, let's say you have a large polygon, very large. It has like, let's say 100 sides. So for this vertex, how many options, how many diagonals can you make? Starting at this vertex, you can connect it to every vertex except this one and this one. So you will have n minus 3 options. So for every vertex, you have to connect it with n minus 3 different vertices. And now if you think you are overcounting every diagonal twice. Starting at 1 and starting at 3. You are overcounting every diagonal twice. So it is like you have to divide by 2. Okay. So you can do it anyway, and there are 2 ways to think about the problem, and these are the 2 ways. So this is how you calculate the number of diagonals in an n-sided polygon. Cool. So this was a brief introduction about combination. We have learned permutations and combinations. So what are the major differences between these two? The first very basic difference, combination is arrangement. Permutation is arrangement. Permutation means arrangement. Okay, permute, the English term means arrange. So here you are arranging objects, and here you are only selecting objects. Okay, and here does order matter? In arrangements or in permutation, order does matter. Order matters. In combination, the order of selecting the items doesn't matter. You are just selecting them, okay? The order doesn't matter. So that's the main difference between permutation and combination. So there is a, like on a lighter note, so this is called a combination. This is called a combination lock, okay? You try all possible combination, but actually it should be called permutation lock because you are arranging the words, okay? So it is named wrong, and still we are using the same name. You're actually doing permutation in a combination log. So yeah, cool. Thanks a lot. We'll meet tomorrow. Bye.